Hey guys, welcome to the 1.5 two variable inequality notes. What we're going to do is graph linear inequalities on a coordinate plane or a grid, and then we are going to find the area of the solution if it is a system of inequalities. So what we're going to basically do is plot our points like we would to graph a regular line, but then we're going to connect them with either a solid line or a dashed line, and then we're going to shade either above or below. So basically the only difference is you need either solid or dashed, and you need to shade it afterwards. So first things first, if it has the little equals to bar underneath, like these two, that means that you're going to draw a solid line. And if it doesn't, then you're going to draw a dashed line. So bar, solid, no bar, dashed. Then, whether you shade above or below is based off of whether it's less than or greater than. So these two over here are less than because the pointy end is on the left, so we're going to shade them below. Hopefully it seems kind of natural that less than would go below, and then greater than, where the pointy end is on the right, will be shaded above. Okay, up for greater, down for less. Okay. Alright, so here's our first example. I'm going to go ahead and point out the symbol before I move it. It's less than or equal to, which is solid line shaded below. So what I'm going to do is start at positive 3 because that's my y-intercept. Boom. Then my slope is negative 2, or negative 2 over 1. What that means is I'm going to go down 2 over 1 to the right. So from the point I already drew, down 2 over 1 to the right. Down 2 over 1 to the right. Down 2 over 1 to the right. And then I'm going to draw a solid line through these. Make sure you check that part before you draw your line. It's kind of annoying to go back and change a solid line to dashed if you have to. And then it says shade below. Easiest way to do that is to start on any point and go down. So I want this half of the graph to be shaded. Like that. That means that any point in this area is a solution, like 0, 0. Negative 1, negative 1, negative 2, negative 2, and so on. Anything in this area. Alright, next one is a greater than symbol, which is dashed and above. So I'm going to start my line at negative 2 because that's my y-intercept. And then I'm going to go up 1, right 3. So remember that for your slope, the first number always tells you how much you go up or down, then how much you go left or right. So from here, up 1, right 1, 2, 3. Up 1, right 1, 2, 3. And then this time I'm going to draw a dashed line. Here's how I do mine. I just drop it, break, 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 break. And the lovely features of this room are the lights turn off sometimes. And then I'm going to shade this one above because it was greater than. So this time anything up here is a solution. Alright. Now this next one is not solved for y yet, and I need to do that. So what I'm going to do is subtract this 2x to the other side. Remember that we like to put it in between the symbol, it was an equal sign before, and the 9. So that gives me negative 3y is less than negative 2x plus 9. So I'm just moving this over to the other side. It's becoming negative 2x. Then I need to divide everything by the negative 3 that's in front of y. And since I'm dividing by a negative, this sign has to flip. Okay, my negative 3's cancel, and I just have y. And then, since this is two negatives being divided, I'm going to go ahead and make it a plus. Positive 2/3 x. And then 9 divided by negative 3 is negative 3. So my line is going to start at negative 3 on the y-axis. And then my slope is 2/3, so I'm going to go up 2 over 3. Up 2, right 3. Okay, up 2, right 3. And then I have to go check. This is a greater than, just like my last one, which means that it's going to be a dashed line, and I'm about to shade it above. And then I'm going to shade this whole area up here. Notice how no matter what, I'm shading all the way to the edge of the graph and all the way up to my line. Okay? And then we have kind of a tricky one that ends up being not too difficult at the end. Y is greater than or equal to negative 3. First of all, this is going to be a solid line that we are going to shade above. So I'm going to go to where y is negative 3. And then this is where it gets a little tricky. That's all there is. There's no slope on this one. So I'm going to kind of remind you of this thing we had talked about, Poiluxe, where horizontal lines are written as y equals, vertical lines are written as x equals. Since this one is y equals, that's horizontal, meaning we're going to go like this. Another easy way of remembering it is that this is where y equals negative 3, so is this. So I can pick any x value I want as long as y is negative 3. And then I'm going to shade above. Done. Okay, let's flip to the back side. A system of inequalities is just a fancy way of saying two or more inequalities. And the solution is the overlapped area where both are shaded. Okay, so all that's going to happen is we're going to graph both of them and then look and see where they are both shaded, and that's going to be our final solution. Okay. So for this one, I have negative 2x plus 9. I know that this is 7 here at the top, so I'm just going to go 8, 9, and kind of make that myself. And then I'm going to go down 2 over 1. So down 2 over 1. Down 2 over 1. Ooh, there we go. Okay, and then this is a less than or equal to, so I need a solid line that I shade below. And I'm going to do this one all in orange to make it a little bit easier. And notice how I'm trying not to shade too dark right now, because I'm about to put another line on here. And then this line is a greater than, meaning that I need a dashed line that shades above. So I'm going to start at negative 4 and go up 1 to the right 3. Up 1 to the right 3. And then I'm going to shade this one above. So this area right here where I've shaded both, these are my solutions. So what I'm going to do is shade them really dark. You guys can even go as far as erasing these two chunks if you want to. But this is your solution area. That's it. Just make sure that you clearly mark it by either shading really dark like this or by erasing the other parts. Okay, now this one freaks people out a little bit because it's got 3, but this one just says x is greater than -6. Following Hooyvuks, it's x equals, so that would be a vertical line at -6. So here's -6. And I need to draw a dashed line because I have no equals to bar under there. And then this one typically confuses people a little bit because there's no above or below. If we want x to go greater than -6, is that going to be this way or this way? Look at the x values. This way. Then I have x is less than or equal to 4. So again, a vertical line, but this time at 4, and I get to draw a solid line because there's an equals to. And then less than means to the left. Okay, so right now our area of solution is just this part in the middle. And then it says y is greater than x minus 2. And I'm going to put a 1 in front of there. 1x minus 2, so I'm going to go to -2. And then for my slope, what I need to do is go up 1 over 1. Up 1 over 1. Okay, so the slope of 1 just goes up 1 over 1 all the way across. Since it's greater than, I need a dashed line because it does not say or equals to. And greater means to shade up. So this area right in here is my solutions. Because all 3 of them have to be true. Alright, moving on. The absolute value of y is less than or equal to 4, and the absolute value of x is less than or equal to 3. So what this is saying, absolute values mean distance from 0. So this is just a fancy way of saying y is between -4 and 4. So I'm going to put a line where y equals 4. And I'm going to draw a solid one because it's or equals to. And I'm going to shade in between them. Then this one is saying that x is between -3 and 3. Now, before I go any further, I'm going to say absolute value means that the absolute value of 4 is 4 and the absolute value of -4 is 4, because it kind of turns anything that's negative into a positive. But if I start at 0 and I want y to be closer than 4 to 0, that's going up 4 and anything closer. We're going down 4 and anything closer. And for x, I want it to be within 3. So I'm going to go out 3 and draw a line going up and down for x, or I want it to be closer. Or I can go to the left 3, and I want it to be closer. So my solutions are right here. And then I'm going to go back and read the directions. It says, then find the area of the solution region. So I need the area of this. Well, it's a rectangle, guys, and what's the area of a rectangle? Length times width. It does not matter which one you consider your length and which one you consider the width. I'm going to call this one the length. It is 1, let me go right here, 1, 2, 3, 4, 5, 6, 7, 8. And my width is 1, 2, 3, 4, 5, 6. And 8 times 6 is 48 units squared. And we do not know what our units are on this one. So, that's it. So you do have to look at what shape you have. Okay, coming over here, I want x to be closer than or equal to 5 from 0. So 1, 2, 3, 4, 5. And again, I'm drawing a solid line because it's or equals to. So I just go 5 in either direction for x. And I have to shade somewhere. I have to shade all this area in between. Y is greater than or equal to -4. So I'm going to go to -4, draw a solid line because I said or equals to. And I'm going to shade above. And I'm going to go ahead and just keep it in between those two lines because I know I don't need this area anyway, since my first line didn't shade there. And then here's the different part. We need 1 over 1 x plus 3. And we're going to shade below because it's less than. Go to 3, up 1 over 1. There we go. And then I said I needed to shade below, right? Okay, now the question is, do you know what shape this is? It looks a little funky, but this is a trapezoid. Normally they look something more like that. But their area, and it's okay if you have to look up an area formula, is 1/2 times the height times base 1 plus base 2. So for this one, keep the 1/2. The height is the side across from the slanty side. See how these two are parallel? Those are your bases. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I'll add together these two sides. So this one is 1, 2 plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm going to go ahead and do half of 10 because I already know what that is in my head. 5. And then 2 plus 11 is 13. And 5 times 13 is 65 units squared. So basically, to find the area, you have to decide what shape it is, and then look up the area formula for that if you don't already know what it is.